Welcome to another session of Ebenezer Gate coaching classes. This is a problem that appeared in GATE 2015. It's a multiple choice question for 1 month. In the circuit shown has to function as a clamping circuit, then which one of the following conditions should be satisfied for the sinusoidal signal of period 2? Now, what is a clamping circuit? Clamping circuit is a circuit where the capacitor is charged to the peak of the input signal, and then because of the capacitor, the voltage remains at the capacitor voltage plus the input voltage, and thereby making the diode in the off state, and the output will be a positive output. So here in this diagram, the capacitor is going to be charged to the peak. So let's say the peak is Vm. So the capacitor will be charged to Vm. So after the capacitor is charged to Vm, so the output will be actually minus Vm plus Vm sine omega t, or the output will look like this. 0 will become minus Vm, Vm will become 0. This will be the output of this circuit. Now, this is valid only if the voltage across the capacitor does not decrease much during the complete cycle of the sinusoidal waveform. So if that has to happen, then the discharge of the capacitor should be very, very slow. So if the discharge of the capacitor should be very slow, the time constant of the RC circuit should be very high. So RC should be very high compared to the time period of the sinusoidal wave. So the option is D, because in a clamping circuit, we don't want the capacitor to discharge fast. We want the capacitor to discharge very slowly, extremely slowly. So its time constant RC should be very much higher in comparison to the time period of the sinusoidal signal. So the answer is RC very much larger than capital T. That is option D. Thank you. God bless you.